AI just got crazy. You can swap your face into any motion control, and I'm going to show you how. Kling 2.6 is the hottest thing in AI right now. And in this video, I'm going to show you exactly what's new, what it can and cannot do, and how you are going to level up your creations. All right, so first, what's new with Kling 2.6? So first of all, you've got native audio. Kling has just introduced audio to its video generation, and that's pretty much the norm now, looking at Veo 3 models and Sora 2. Kling 2.6 is aiming for audio and visuals generated together, dialogue, ambience, sound effects, and even musical outputs. So the final result should feel like a cohesive piece. Second, voice control. Now this is where things get a bit spicy, because it's not just generate a random voice. The idea is you choose a target voice style, and Kling tries to replicate its characteristics for your specific content, so that you can keep consistency across clips, characters, and episodes. Third, reference images. The deal here is flexibility. Instead of being forced into first frame and last frame style control, you can feed it references to steer character identity and visual design without needing a rigid structure. But motion control is the biggest update for me, and this is why it's the most talked about model right now. Because once you can transfer performance, AI stops being general and becomes specific. What is Kling Motion Control? Here's a simple explanation. You upload a driver video, which is a performance with motion and expression, and you also provide a character image, which is the target look. Kling extracts the choreography, timing, and facial cues from the driver, then it applies it to your character, and your prompt mostly becomes the context glue. So lighting, environment, style, mood, rather than make this character wave his arms. So video equals choreography and image equals identity. Now, before we dive deep into my tests, let's quickly go over the examples released by Kling. Now, bear in mind, this will be the best case scenario outputs. So I watched them closely, and here's what kept on showing up. The driver and the target character need to be similar enough that Kling can map the motion without hallucinating the anatomy. Male driving a male tends to work better than a male driving a female. Similar silhouettes help, similar proportions help. You want clear separation from the background and good lighting. If the driver clip has insane speed, messy occlusion, or complicated overlaps, your results tend to collapse. And that leads me to my tests, to see exactly what it can and what it cannot do. I wanted to explore how it held up with basic male to male, male to female, speech and lip sync videos, using props, complex motions, for example, overlaps in interactions, cuts in the driver video, human driving an animal, and animal driving to an animal, and finally a busy scene with multiple people. And to run these tests without getting blocked by strict guardrails, I used Higgsfield to access different models and workflows through the use of APIs. This lets me iterate faster without getting stopped every 5 seconds whilst I try to recreate a person's likeness. Now bear in mind, I'm using this for testing and educational purposes. Now starting off with basic male driver to a male identity. I kept the driver simple, then I kept everything the same in the reference image. Lighting, framing, background, and only swapped myself out for various characters using Nano Banana. And instantly, I thought this was dangerously good. I was surprised with how well hair held up and how well body movements worked, even micro shifts that felt believable. Kling also added a prop that wasn't in the reference image, like the sword we see appearing when the Witcher stands up. I actually loved that because it revealed an understanding. It's forced to start filling in the gaps to keep the fantasy consistent, and that's good until it's not. Because the second I started pushing it to more complex or unusual characters, the cracks started to appear. Gollum picks up a weird black halo around his silhouette like a poor rotoscope. Whilst Jack Sparrow moves, he randomly picks up his pistol. But those are the kind of issues that often vanish when you rerun generations. I like the fact they added fingernails for the Kylie Jenner generation, once again showing understanding. Then I tried to level it up by adding a text instruction, such as make Hellboy's horns grow during the performance. And that didn't work, but that makes total sense. Probably something to prompt in afterwards. Once again, I gave it a harder identity problem, this time using Davy Jones. It's got to tackle tentacles, detail, and a lot of chaos. If Kling nails the tentacle movement while staying sharp, I would have lost my mind. But in fact, it was very mediocre. Some slight tentacle movement, but overall the output ended up having that smooth AI look. It was trying to calculate too much. Too much detail, too much motion, so it started averaging out. Of course, I had to do what everyone wants me to do and put yourself in a movie. I grabbed the frame from The Wolf of Wall Street, face swapped, and used the original scene as a driver video. What I was paying close attention to wasn't necessarily the face. It was the interaction with the environment, when he rises behind the stairs. It didn't fully nail it because the model doesn't have the full information about the hidden angles, One front-facing image reference doesn't carry enough data to fully understand what the eye can't see. So I switched to a shot where everything stays a bit more front on, and it improved. But honestly, recreating a Master DiCaprio performance isn't just facial motion. It's in the little things, the micro-emotional shifts, and that's the character's magic. The next test for me was trying to replace Jake Paul's face with mine. Nano Banana tends to not handle face swaps as good as I'd like it to. I found that swapping out the character completely works much better, but the first attempt failed because the driver video didn't show the body clearly enough. Obstructed view due to Anthony Joshua in the way. Then I saw a Muppet version of Jake Paul and thought, this must be motion control. I then figured out it was just image to video. Now, animals. I've seen Luma Ray 3 push for human performance to animals, which gave me hope. So I tried animal to animal first, a clear cat driver with a tiger reference, but no joy. Then I flipped it. Human drives animal, because I've seen clips online you can literally spot a driver's arm influencing a horse. So I tested a capybara. I thought similar features to a human, four-legged if I put it stood upright, clear facial recognition as well. But that failed. Therefore, I picked a meerkat. More human-like limbs and proportions, and it worked. This was a major insight for animal motion control, as it seems to need human-readable anatomy. 2 arms, 2 legs, a head shape that's representational of a human. Otherwise, the motion translation doesn't know where to go. I was really impressed by this generation, especially within the fur. But the meerkat result wasn't perfect. Background foliage glitches as it tries to add motion and interactions, subtle morphing, out of focus recalculations, but the performance read really well. With a more static background, dropping the foliage that would naturally move in the wind, I think would lead to greater results. So using that theory, I used our closest relatives for the next identity, a monkey in a jungle. I gave it a more complex driver video, and it held up well until close-up focus shifts. The hands got messy, inner arms lost detail, background did a weird morphing thing as it's trying to interact with the character, but it's trained to create static backgrounds, and it makes sense. When you move fast or you turn away, the model has to invent missing surfaces. Without multi-angle references, like a pose sheet, it guesses. Hence why you can see creases at the back of the monkey's leg from the driver video trying to replace the missing information it cannot see. So the next generation, I wanted to see if it could handle props and costume. So I kept the reference image similar to the driver video, a warrior wearing a helmet, but this time changing the environment. I thought the facial movements came out strong, although the lip sync wasn't right at the start. The major issue for me, and it's clear, is the frozen backgrounds. Not just the backgrounds, but the foreground as well. You can see that only the character moves, and the snow in front and behind it stays perfectly still, showing an understanding of layers. I then reran the prompt, this time getting a couple of snowflakes trickling down. I wanted to then explore how it could handle cuts in a scene. I was skeptical, because if this can handle edits, it becomes insanely usable. It struggled. It ignored parts of the driver video that I wanted, where Achilles places down his spear, and it jumped to the close-up shot instead. Any prop interaction like helmet removal went off the rails. Helmets would disappear then reappear. The hands went weird, but I really wanted to push it for snowfall. Therefore, I tried again, and this happened. It actually handled snowfall. But then I realized I haven't actually given the image a prop to match the driver video. I wanted to add a more complex background and populate it with people. Would they get the motion? But knowing that all backgrounds have been frozen so far, this felt like a dead end. Sadly, it was just more of the same as the previous. Even though the motion neglects the backgrounds, I still wanted to try and push the motion's performance to the max, keeping everything similar to the driver video, just changing the costume. So everyone looked like a Spartan from 300. This would give it the greatest chance of success. Now, I don't have much hope for this one, but I was very surprised. It handled everything pretty well other than the glitch on the shield. The cloak's physics were believable, but how would it handle the new character that wasn't in our input image, which it completely neglected? Therefore, I tried again, this time adding a second character into the input image. It started off promising, but then it quickly collapsed. I did notice some promising takeaways. For instance, the dust that gets kicked up, and also the speed of the motion. Normally, AI slows that way down. I did an attempt with Darth Vader, but this was a big fail. It looked plastic. The initial image I gave it wasn't the greatest. Of course, I could not neglect this scene. It's too iconic for me. Focus here was checking on how it handles the turnaround and the removal of the helmet. I thought that if I used a popular character like Christian Bale's Batman, it would understand the costume even if it wasn't in the visual prompt, so that the integrity of the facial features were intact. But I was still intrigued and I felt that I didn't cover all bases. Therefore, I went bigger. Fight choreography with multiple people. A 2-person fight in one clean take failed repeatedly. So counterintuitively, I tried 3 people. And to my surprise, it was an actual hit. But it was absolute gibberish. Yet the fact it could assign motion to 3 separate identities was in fact very promising for the future. Now, this next shot failed. Not because of the motion, because that was actually quite good. Look at the hair and the chain physics. But once again, due to the frozen background breaking the illusion. These pirates should be working away, moving. And then the hat interaction again failed. Now compare that with what is going to be the best generation we've done so far. The motion is fast, the character is consistent, there is subtle camera shake, but this isn't the reason it works so well. The reason is because of the background. In this scene, the characters can get away with not moving. But look closely, some of the militia pick up the same motion control as the driver video. Look at their mouths. Now look at the horse. He's not frozen, there's subtle movement there. Now, can it handle complex camera movement? The answer in short is no, absolutely not. Check out this Gary Oldman video and the recreation of scat from Ice Age in Mount Doom. As visually clean as these videos are, the complex camera motion is understood by the viewer due to its surroundings, i.e. the background moving, which we now know isn't possible in Kling Motion Control. I still needed to make props work and interact with human performance. I knew just the video for it. We do actually get a slight attempt of the spear or bamboo about to be placed into the ground, but yet again it hasn't quite captured the full motion. Side note, we do get some jungle leaves rustling. I wanted to adapt the dance scene from Wolf of Wall Street, and maybe the In-Betweeners too, but that didn't work either. 1, it has a crowd of people. 2, a woman crosses the front of the frame. Can it handle it? This is surely set up to fail. What annoyed me most was Nano Banana's failed attempts of a face swap yet again. So I pivoted and I changed the scene completely. But yeah, it was too complex for any good results. Therefore, I took it back to basics. And I promise you, this was the best generation, and I'm going to tell you why. The driver video was clean and clear. Still with some complex hand movement, overlapping, etc. But nothing too crazy. The identity image was made from a simple background that was out of focus, leaving all the detail on Bruce Lee. It came out top. Just look at the detail and the understanding of the musculature, tensing and flexing as his arms move, folds in the creases in his skin, and even subtle stretch marks. Just wow. Like, wow. Now for my final attempts, I wanted to nail the props. But therefore, with a simple input video of me removing my hat, I tried to recreate a clean version, as I knew prior that helmets had caused issues. It started off promising, but the same old hat tricks appeared, and the tattoos got a bit loose too. Having said that, the facial expressions were top. The same running theme applied for the next 2 generations of Rowan Atkinson. Still not handling the prop even when I included it in the visual prompt, but what I would say is the best performances happen with the close-up shots, due to the amount of pixels it can work with to create these emotional changes, which is unlike medium shots where it has to split pixels and guess where each belongs. Right, to finish off, I had to leave us on a Joker performance, focusing on subtle facial cues and having my tongue as part of the performance. I mean, this was super fun to create. Well, what a powerful tool that will have big impacts on the way we work. It's exciting to see where things are going. I'm sure later down the line we'll have multiple character motion control with moving backgrounds, but the quick takeaways for prompting your videos are as follows. Clear driver video. Lighting, separation from the background. Not overly complex performances. Match the driver video. Similar composition, silhouettes and shapes. Right, for image identity, keep backgrounds simple. Restrict movement and put them out of focus. Thanks for watching. Don't forget to like and subscribe for more creative content like this. Catch you in the next one.